4.5, it begins the unit of graphing the sine and the cosine functions. And in order to do so, you must understand the amplitude, what the amplitude is, the period, the phase shift, and the midline. So today we're just going to analyze graphs and talk about those four things. First of all, when you're graphing trigonomic functions, you don't have a typical XY plane. Instead, what you have is you have an independent axis, which is the angle of measure. It's usually in terms of radians. It doesn't have to be. Could be degrees, but we're going to do mainly radians. And then you have the length of the triangle, which is the dependent axis, which was typically the y. And this is going to represent the sine or the cosine. So the length of the leg, either the x or the y, and at each radian measure. So for example, if you look at the unit circle, the radian measure right here, that's what would go on the independent axis, so the x-axis, what you're familiar with. And then the length, so either if we're talking cosine, it would be the x value here. That would be on the y, so the height, or if you're talking sine, it would be the y value, again, for the height on your dependent axis. And one important thing we need to start with is understanding what a cycle is. So a cycle starts and ends in the same spot, having completed one full function, okay? You can notice as soon as we have this point to this point, we start repeating itself, okay? This is repeating. We've already had that over here with the original. So this particular one has 3 cycles, one here, one here, one here. Of course, it goes on forever, so it has an infinite number, but what we see is 3. All right, here are those 4 key words in which you need to know and understand. So amplitude, A, stands for the height of the function. So this is the height above and below, above and below. So for example, if the amplitude, on this one, the amplitude is 2, because here's the midline right here. And we're going up 2 and we're going down 2. So for this one, the amplitude is 2. I'm going to go to this last one here, the vertical shift or the midline. The midline is what we have here. I have it as baseline. I'm going to change that to midline. The midline is the center of the function. Center of the function. It divides the function in half. Half of it, you'll notice, is above, which is the amplitude, the height, and half below, again, the amplitude, the height. I'm going to go to this one here, the phase shift. The phase shift is the right or left shift of the function. And the period is the time it takes for one full cycle. So time required for one full cycle. So for example, if we start here, we need to end in that same spot, having to complete one full cycle here. The period would be 2 pi, because after you come to this point, you start repeating it. So for this one, it is 2 pi. It doesn't have to be. So we're going to start with an example on finding the amplitude, period, phase shift, and midline. And what you should do, I'd recommend starting with the midline. So you'll determine where you think the center of the graph is. And it looks like it's here at -1. And just to make sure it's correct, the next thing we're going to do is jump up to the midline. We need to make sure we're going up and down the same amount. So we're going up 1, 2, 3, and we're going down 1, 2, 3. So we have an amplitude of 3, and we can now see that that is definitely the midline. The period, again, is the time it takes to complete one full cycle. So I'm just going to start right here at 0. That's the easiest. And I'm going to keep taking my pencil until I get back to that same point right here. And notice this is one cycle. As soon as I go here, I've already repeated that here. And then I'm just going to go up to see where that took place, and that was at pi. So the period is pi. The phase shift, we're not going to worry about that today. We're just going to look at the amplitude, period, and the midline, because we don't know the phase shift unless we know it's sine or cosine. Okay, here's another example. We're going to start again with the midline at the bottom. It looks like my midline is 1. And notice I'm dotting this because that's what we're going to do when we're graphing it. If my midline is 1, I have to go up and down the same distance. So this is going up 2, and this is going down 2. So my amplitude, or my height, is 2. My period, well, let's see. If I start here on 0, follow this through, I need to get back down here. And whatever this is my period. So I need to determine what that tick mark is. And you're going to notice each of these are pi over 2. Here's half pi plus another one. Here's pi, 1.5 pi, 2 pi, 2.5 pi. So this is going to be 3 pi. So the period there is 3 pi. And again, don't worry about the phase shift. All right, you can try this one. You should have a midline of 0. You have an amplitude of 3. The period, we're starting right here. And as I go back around, this one's tricky because we're not stopping here because we have not yet done this part. So we're going all the way around to this in order to get our period. So the period for this is at 8. This one is not in terms of radian, it's just a number. Well, it could be. You could divide that by pi and then it would be. And again, there is no phase shift. The next thing we're going to do is just look at the equation and determine where the amplitude, period, phase shift, and midline come from. So we have an equation. It could be sine or cosine. We have an A, which is first, a B, which is always on the outside of the parentheses. If it's not outside of the parentheses, we have to factor that out. I'll talk about more of that in the examples. We have the C, which is inside, attached to the X, and D, which is on the outside. And the D on the outside could actually be up in the front right here as well. So just make sure it's at the end. All right. A, amplitude, is the A value, and it's the absolute value of whatever number is first. So it's always going to be positive. The negative is just going to be a reflection, just like we dealt with any transformations. I'm going to jump down to the last part here. This actually goes in order. This is the A, this is the B, this is the C, this is the D. But I'm going to go to the midline. The midline is the D right here. That, remember, was the up and down shift. So this is the center of the graph right here. Center. The phase shift, the C value, just like when you do any transformations, remember it's inside attached to the X. It affects the X in the opposite direction. So this is going to be a right or left shift, and it's going to be in the opposite direction because of that subtraction sign there. And the period, remember, is how, when we start repeating a function, okay? But the B value is truly represented by the speed of the function, okay? The speed of the function, which is not the period. So we have to do some calculations to determine the period. So let me give you an example for a second here. If you look at that B value, if that B value would be a 2, it means it's going to go twice as fast. You will complete 2 cycles because on the interval of 2 pi, because it's going twice as fast. If it would be 1/4, it would be going 1/4 the speed, so you would only finish 1/4 of the cycle on the interval of 2 pi. So notice I kept saying 2 pi. Well, here our period is going to be found by taking 2 pi and dividing it by b. So this one right here we actually have to do calculations with. It's quite simple, but this is commonly forgotten. And take note of what it says down here. Functions always have an A and a B value, but they do not have to have a C or a D, so those could be 0. In other words, there would be no phase shift left or right or no phase shift up or down because D is the up or down phase shift. It's on the outside. It affects the function in the same direction, the Y value. All right, let's take a look at a few examples, starting with this first one. All right, we have an A value on the outside, B value, which has to be on the outside of the parentheses, which it is, the C value right here, and the D value right here. So in determining that, the easiest one is the amplitude, because it's the first number. Remember, it's the absolute value of that. It's already positive, so we don't need to worry about that. So the amplitude is 5. I'm going to jump down to I'm going to put A, B, C, D, but I'm going to jump down to the midline. The midline is right here. The midline is at -4. I'm going to then go to the phase shift. As long as there is no number in front of the x, this is going to be the phase shift in the opposite direction. So because this is a plus, it's going to go either left 2 pi, or you could also write it as a -2 pi, meaning it's going to go left 2 pi. The period is the one thing we have to calculate, and the period is equal to 2 pi over b. So we are going to take 2 pi and divide that by our b value, which is 1/2. And remember, we can't divide by a fraction. Instead, we change that to multiplying by the reciprocal. So when we change that to multiplying by the reciprocal, this is equivalent to 4 pi. So our period, when we complete one full cycle, it'll be on the interval of 4 pi. So if you take a look here, like I said, this b value is the speed of the function. It's going half as fast, so it's going slower, which is why we won't complete a full cycle until we're at 4 pi. So it's more spread out like this. That is something that's slowed down, versus if it was faster, it would go like this. Okay, let's look at the next example. Again, we have our a value here. The b value is outside the parentheses, and notice you have a number here. We're going to have to factor this b value out. This will be the c value after we factor the b value out, and there's our d. So the easy ones are the a and the d, which is where I'm going to start. So the amplitude is the absolute value of that. It is a +4. The negative is a reflection. We'll talk about that when we start graphing tomorrow. The midline is -6. That's the center of the graph. And in order for us to get the phase shift, like I said, we have to take this b value and factor it out. So I have to take and divide this by 2 and this by 2. And when I do, what's going to happen is I still have the -4 cosine. The 2 comes outside. You see that simplifies away, and we're left with an x, which we have to have. This has to be a 1x here. And 4 divided by 2 is 2, so that's equal to 2 pi. Now we can see our b value is 2, which we're going to find our period from, and our c value is right here. So this goes in the opposite direction. So now we're going to go right 2 pi on this one, or a +2 pi. And our period is 2 pi divided by b. So when I take my b value, which is now 2, easy math that time, my period is pi. Reason being is because usually one full cycle is completed on the interval of 2 pi's, but now we're doing 2 cycles. It's going faster, like this one right here. So 2 cycles on the interval of 2 pi. I'm going to run through this next one rather quickly. I want to do this because to show you that here's the a, here's the b. There is no c, there is no d, because this would be in parentheses. There's nothing added or subtracted here. So for this one, the amplitude is the absolute value of this, so 3. We have, B, C, D. We said there was no phase shift. There was no there is a midline. The midline is just at 0, okay, because nothing is added or subtracted to this, so there's no shifting up or down. And then the period is 2 pi divided by b, and our b value you can see is pi, so 2 pi divided by pi is equal to 2. Now you're probably saying, wait, that doesn't make sense. I thought that had to have a pi in it. It usually does, but there's some exceptions, and this is one of them. Okay, let's take a look at the next one. The next one has this coefficient here on the x that needs to be factored out. So we're going to take and factor the 4 out. So we'll divide this by 4 and divide this by 4. What we will get then, I'm going to rewrite it down at the bottom here. The 4 comes out, We're left with a 1x, which is what we need. And here we have pi over 4, or I could write 1/4 pi. And going through, here's our amplitude, absolute value of that. So we have 2. Going to the midline at the end, there is no d value. There's nothing added or subtracted, so that is 0. Our b value is 4, so if we take 2 pi and divide it by b, you're going to see that what we're going to get is pi over 2. We are going 4 times as fast, meaning we are completing one full cycle at pi over 2. And the phase shift is in the opposite direction here, so it's going to go left, pi over 4, or you could have written negative pi over 4. Either one is fine. My preference would be this one. There you go. Now, feel free to try both of these, but I am going to talk about the phase shift with these because both of them have a leading coefficient in front of the x that has to get factored out. And I want to talk about how you do the math on both of these. So the first one, we have 1/2 sine. We're pulling out the 2, so we're dividing this by 2, which is going to leave us with an x. And then we're dividing this second term here by 2. And this is already being divided by 2. It's just going to join that 2 down there. So this is the same as pi over 4. Now looking at the other side, when we're factoring out the 1/2, we're dividing by 1/2 and dividing by 1/2. And 1/2 divided by 1/2 we know is 1, so this is pretty easy. Here's where it gets a little more complicated. But we know how to do this because we know this is the same as this. We also know we can't divide fractions, so instead we multiply by the reciprocal. And look what happens. Those simplify away. We're left with pi over 2. So what we are truly graphing, or the equation that we truly have once we factor out that leading coefficient, is this right here. Now, if you want to pause the video, you can go ahead and find the amplitude, period, phase shift, and midline, and then check your answers upon coming back. And check your answers, and a couple of things I want to emphasize. The amplitude, you have to have an amplitude. It's always the number right here. If that were 0, there would be no cosine, and you would not have a trig function that you could graph. And then don't forget your right here. And when you're dividing by 1/2, it's the same as multiplying by the reciprocal, which is how we get 4 pi. So hopefully you got those correct. And with that, your homework is worksheet 4.5a. You can pull off a Schoology and submit it when you're done. Have a great day. Bye.